Alrighty, so today we're going to be looking at some applications of trigonometric functions, but to begin with we're just going to be doing some really quick converting from t, a variable, which is going to be defined as the number of hours after 6 a.m, and actual times like 6 p.m, 4 p.m, 9:15 a.m. So 6 a.m. would actually be t equals 0, because it's 0 hours after 6 a.m. So we're just going to count how many hours are there between 6 a.m. and 4 p.m. So you could just count with your hands, 7, 8, 9, 10, 11, 12 p.m. 1, 2, 3, 4. So that's 10. So for part A, we could find out t is equal to 10. The other way you can think about it is 4 p.m. plus 12 hours would take you to 4 a.m. Oh, sorry, 6 a.m. plus 12 would take us to 6 p.m. and then take away 2 hours, and we're at 4 p.m. That works as well. For B, the main tricky part is the fact that we've got a 15. 9:15 a.m. is 3 hours after, so it'll be 3 point something. In this case, 15 minutes is quarter of an hour, which is 25 minutes. Just as a reminder, 0.15 times 60 equals 25 minutes. Alrighty, so let's have a look. There's a few questions underneath if you're interested. Otherwise, let us carry on. Alrighty, so if t is defined as a number of hours after 9 a.m, write each of the following values as t as time of day. So t equals 8. Alrighty, so we're counting 8 hours after 9 a.m. 10, 11, 12 p.m, 1, 2, 3, 4, 5. So we're going to get that for A, it is 5 p.m, which is 8 hours after 9 a.m. Alrighty, the second one for part B is 2.2. The 2 is easy. That's just going to be 11 a.m. The interesting part is the 0.2. 0.2 is times 60, gives us 12 minutes. So it's going to be 12 past 11 a.m. Alrighty, so it's converting time. This is useful because on a lot of trigonometric questions, we're going to be using t, our x variable, as time. And usually it's going to be either in minutes, hours, or even, as in this case, seconds. So let's have a look at a question that involves a trigonometric function. A Ferris wheel with a radius of 30 meters rotates once every 60 seconds. Passengers get into a cabin 1 meter above level ground. Alright, let's draw a quick sketch. So to begin with, let's draw a little Ferris wheel. Right, and there's a cabin 1 meter above the ground. Now the radius of the Ferris wheel is 30, which means that the whole diameter is going to be 60 meters. Well, that tells me that from the bottom to the top is going to be 61 meters. And that means halfway in between is going to be 31 meters. Right? You think about it. If it was touching the ground, then it would be 0, 30, and 60. But obviously it's actually one step above. So this tells us a lot of information. First of all, it tells us our median value, 31. Well, because it's halfway in between the minimum and the maximum. The A value is going to be 30, right? Because that is the distance between the median and the maximum, or the median and the minimum. Alrighty, let's have a think about the period. Well, it says in the question that the period is 60 seconds. Alrighty, well, using our formula, 2 pi over b is equal to 60. Alrighty, rearrange that formula, we're going to get 2 pi over 60 equals b. b is equal to pi over 30. Alrighty, one problem though. If I have a think about it, this is a function starting at a valley, right? Because you start at the bottom of the Ferris wheel, in the dip, not at the peak, not at the top of the Ferris wheel. Now, there's a few ways we could play with this. We could do a period shift, but that's a bit of hard work. So instead, what I'm going to do is I'm just going to reflect the function in the y-axis. Now, the other thing is that because it is starting in a valley, not in the middle, that means it's going to be a cosine function. So h of t is going to be a cos function, and in particular, it's going to have an a value of negative 30. It's going to have a period of pi on 30 t, and it's going to have a d value of 31. And there's my function for part A, h of t. Alrighty, for part B we just need to do a little sketch. So let's do that. Alrighty, so for our sketch, let's set up our axes. So on our x-axis we're going from 0 to 60 to 120. If you read the question, it does in fact say that it is going for 2 minutes, which is 120 seconds. Now our y-axis is going to be at the minimum 1, at the maximum 61, and in the middle 31. And this is going to be the height in meters. Alrighty, now in order to do my sketch, I know that since it's at 1 here, it's going to be 1 here, because that is the period. 60, that's what the period means, it's how long it takes to repeat. And in between there we're going to have a different number of points. In this case, 15, 30, and 45. One way you can work that out is that a quarter of 60 is 15, so we're going up in 15s. And we continue. Alright, so my axis is sorted, and now I just need to do the cosine shape, starting from the valley. So bottom, middle, top, middle, oh look, back at the bottom. Middle, top, middle, and back at the bottom. And I get the wonderful cosine function that has been reflected in the x-axis. Now really important that we did that reflection, otherwise we'd be starting at the top of the Ferris wheel. And there is my function. Alrighty, moving down onto part C and D. So these are both doing a bit of solving. So part C. Now, we are wondering how high are you going to be at the height of 20 seconds? So what happens when t equals 20? Alright, so we get h of 20. Well, that's going to be equal to minus 30 in bracket cos of pi times 20 over 30 plus 31. Negative 30 cos of, well, pi times 20 is 20 pi over 3. Well, the power of 10, factor of 10 cancels from the top and the bottom, and so we're left with 2 pi on 3. So we get 30 cosine of 2 pi on 3 plus 31. The cosine of 2 pi on 3 is negative a half. And we get 15 plus 31, which is 46. Alrighty, so there's part C done. Now for the last part of the question, we're going to need to use our calculator. Now you can try solving this one analytically, but unfortunately it's not going to work. So we're looking for when the height, h of t, is equal to 50 meters the first time. So if we have a look at our graph, we're looking for a point somewhere around here. So it should be in between 15 and 30 seconds, because at 30 seconds we're at 61, and at 15 seconds we're at 31. So somewhere in between we've got to be at a height of 50 seconds. So let's use our graphics calculator to solve it. So into the graphing mode we go. Now in our y1 we're just going to type our function, negative 30 cosine pi x on 30 plus 31. And as our y2 we're going to put the function y2 equals 50. Okay? And then I'm just going to draw the picture. Now when you first draw it, it shouldn't look nice. You can always do the quick test doing the zoom auto. In this case, the zoom auto may not give you the exact look you're looking for. So we may need to be more specific and be really fussy. So let's set our view window. Well, let's go for the first 60 seconds because we know that it should happen between 0 and 30 from our graph. And let's put our y between 0 and say 65. So we've got a good view of it. Alrighty. Fixed up our view window. Draw the function again. Alrighty. So now we should get a similar picture to the one above, but only this section with a line cutting through there. And we can use the G-solve function, so shift F5, which is F5 again for intersect, and we can see that the first intersection is at x equals 21, which is our t variable, so t equals 21.55 seconds. And if we have a look at the question, it doesn't have any particular rounding rules, but I'm probably going to say after approximately 22 seconds. Alrighty, so that was a quick introduction into practical problems involving periodic functions. Alrighty, thank you, bye.